Well, hi everybody. Today we are going to discuss, or precisely to continue the last session about this chapter 2. So this is the continuation. Alright, in the last video I discussed about the graph. So there are 3 graphs basically in this chapter. Okay, so I will explain just a little bit again. So you have 3 graphs, right? So you have okay. First you have the ST graph. Okay, the ST graph. So the ST graph is the displacement time graph. Okay, so it looks like this. Okay, so this S and this T graph. Okay, and for example, if you have a flat line, so this is a flat line, so this means that the object is not moving or stationary. Not moving object. Okay, so the object is not moving lah. So if you transfer into the VT graph, okay, so the velocity of course will be 0 because it's not moving, right? So this is VT graph. So we can transform from one graph to another graph. So the graph will look like this lah. Okay, so the velocity is entirely 0 because it is not moving. The keyword is it's not moving. Okay, and then we have of course the AT graph. So this is the second graph, the VT graph. Okay, and then thirdly is the AT graph. Okay, AT graph. So you only have 3 type of graph lah in this case. Okay, and if you can also transform from VT graph to the AT graph, so it will be the same. So this is T, this is A, because the velocity is 0, so the acceleration should be 0 too over there. Okay, so this is actually for the flat curve, for the flat line of the ST graph. What if I change to be a straight line? Okay, it's like this. Okay, so this is a straight line. So if you want to transform into VT graph, okay, so it's not like that anymore. Okay, because because this ST graph has gradient. Okay, so it has gradient m everywhere, m and m. So the gradient here actually represent the velocity v. So remember, m is gradient. Okay, m is gradient. Ingat, the formula is y2 minus y1 over x2 minus x1. So this is actually gradient, and the gradient for this ST graph is the velocity. So the gradient is the velocity itself lah. So we can plot into VT graph, so it becomes a constant velocity. Okay, it will be like this. So this is a constant velocity. So does the object not moving? No. Okay, it is still moving, but at a constant rate or at a constant velocity. Okay, and if you transfer into AT graph, so remember previous ST graph, when you have a constant position, you have a 0 velocity, and over here if you have constant velocity, you will have a 0 acceleration. So it will like this. Okay, you need to remember that the gradient for this VT graph is actually an acceleration. So you can see over here the gradient everywhere is 0. So this is actually 0 gradient. So m is 0. Because m is 0, we know that m is a. So automatically a is 0 too. So that's why the graph looks like this. Okay. So what if you don't have a straight line but you have a curve? Okay. So you have a curve. So it will no longer like this. Instead it will become a curve. Okay. It's okay. So we have a curve like this. Okay, so the curve is actually increasing. which means that the velocity is not constant. Why? Because we have a curve over here. So the gradient from there and the gradient to there is not the same. So the gradient of here and here not the same. Okay, so I can write over there gradient not the same, which means because we know that the gradient represent the velocity, so we know that the velocity not the same everywhere. So we can say that we have VT graph like that. Okay, if we transform from ST to VT of a curve, so it becomes a straight line in the VT graph. Okay, and then remember, from the straight line you want to transfer into another graph, it will become the constant or flat line like that. Okay, so I hope you can see the pattern. So the pattern is very easy. So if you have a curve, you just change. If you want to change into another axis, so it will become a straight line. If you have a straight line, you want to change into another axis, you will have a constant graph, constant line. Okay, constant line. And from a constant line, you want to change graph or axis, so it will become the flat line, but at some value 0. Okay, equals to 0. But this flat line is not 0. This flat line is not 0. Okay, it's not 0. Okay, so this is how we transform from one axis to another. Okay, in this case from ST graph to VT graph to AT graph. So we want to transform. Okay, while we transforming, of course the graph should be different for each axis. Okay, all right. So then we discuss about free fall motion. So free fall is basically when object is falling due to the influence of gravitational force or gravity. Okay, so remember, on Earth we have the gravitational acceleration of 9.81 meter per second square. Okay, so don't forget the unit. All right, so you can see over there the guy is jumping from a tall building. Okay, so as he jumps, so he will be acted by the gravitational force. Okay, this gravitational force will act downwards towards the center of gravity. Okay, so this is the gravitational force due to the gravity, which is mg. So you will see later. But because we are on Earth, where we have a air resistance due to the air particle, okay, so our body or an object will collide. Okay, will collide with the air particles. So this air particle will create sort of like resistance. Okay, so there will be a little bit of resistance, or we can say it's air resistance. So this air resistance will slow down this guy from jumping from falling down from the tall building. Okay, so like that. But if you are in vacuum, which means there's no air particle in vacuum, so this air resistance will not exist lah, because we have no air particle to resist the force of the gravity due to the gravitational force. Okay, so this is actually the classic question. Okay, which one falls on the ground first? Okay, 2 kilo or 5 kilogram bowling ball. So Aristotle, okay, said, okay, in the past, that the heavy will fall quicker, okay, than the lighter. Okay, which is not true, because after several millennium later, this guy named Galileo had do the thought experiments. Okay, the leaning tower pizza experiment. So he came to conclusion that any object which falls down from a height, for example, h, okay, height h, so it will experience the same rate of falling, okay, regardless of their masses. All right, so that's the conclusion, which means this bowling ball, so they will touch the ground, at the same time. Okay, at the same time. They will touch the ground at the same time when we release them at the same time. Okay, and at the same position too from the higher position. Alright. But why, if you have a bowling ball and also a feather, according to this logic, I mean the Galileo explanation, the feather and also the bowling should be reaching the ground at the same time too, because the keyword over here is the regardless of the mass, which means that if you have a lighter, doesn't matter you have a lighter or a heavier object, they should be falling at the same rate or at the same time while touching the ground. Okay, so remember I told you about the air resistance. So the feather will experience more air resistance because of its shape, or the aerodynamical shape, which will experience more resistance due to the air as it collides with the air particle. So the feather will be falling down at a slower rate. Okay, while this bowling ball will seems to be falling faster. Okay, because its shape is spherical shape, so it can it will not experience that resistance force so much due to the air resistance. Okay, so you can see this is the flat surface of the feather, and also the shape make it experience greater air resistance than the bowling ball. Okay, so that's why in a normal condition, which means in our earth, okay, in the presence of air resistance, the feather will be slower as it falls down. But if you consider in vacuum, so you can read over here what is vacuum. Okay, so there is no air resistance, so they will fall at the same time or at the same rate. Okay, so this is actually the kinematics equation that we have touched in the previous lesson or in the previous session. So you just change from the kinematics equation. If you see over here, so the value A, okay, A, I just change into G. Okay, A I just change into G, A I just change into G. So anyway, if you see the alphabet A for acceleration, so you just change into G for the free fall kinematics equation. Okay, so they are actually the same formula, but we just change the alphabet. Okay, so this is A to G and this is A to G, and remember G is negative 9.81 meter per second square. Why negative? Because we consider down as negative direction. We consider downwards as negative. Okay, all right. You can also use G as positive, but you need to be consistent in your equation lah. I mean, every time you assign the convention, you need to be consistent all the time, right? Like that. But for me, I prefer down to be negative. All right. Okay. All right. So we come into the Newton's law. We have a first law of motion. Okay. We have a second and also third. So I will explain what is first law. So first law is actually inertia. So inertia, you can read over there the definition. So object will continue its state of motion or a state of rest. Okay, as long as there is no external force. Okay, external force or X on it. So you can imagine there is a ball rolling. Okay, on the desk, or on the floor. Okay, so if the ball is start like rolling or moving, okay, so theoretically the ball will not stop if there is no disturbance or external force. The disturbance here, for example, friction force. So the friction due to the ball and also the floor surface. Okay, so that's the friction. And also when there is nobody touching it or disturb it or stop it. So as long as there is nothing disturb the ball rolling, so it will never stop. It will never stop. Okay, then only if you pick up the ball, you stop it, then it will stop, because you apply an external force, because you are intending to disturb it. from rolling along the way. Okay, so that's the concept for the inertia. So as long as you don't disturb, it will not it will keep moving. Or this rubber ball, okay, so this rubber ball is initially at rest, okay, so which means the velocity is 0. So as long as you don't do anything with this ball, or you don't touch it, you don't disturb it, you don't roll it, it will keeps like that. It will be at rest. It will be at rest forever and ever. Okay. So this is actually the example that I explained in our class. Okay, I don't have to explain this again. So Newton's second law. So Newton's second law is actually the formula lah. The formula what? F equals to ma. Okay. So okay, you can take a look over here. So it's just a relationship between force equals to mass times acceleration. So the relationship of the force can be the product of the mass of the object and also its acceleration. Okay, so you can see over here the proportionality relationship, whereby the force is actually proportional to air, which means if you apply a greater force, okay, so for example you have a toy car. So if you push just a little bit, it will move just a little bit. Okay, so the acceleration will be for example 2 meter per second square, for example. But if you push harder, so if push harder, so F is greater, so the first case is F is smaller, so it will experience a greater acceleration. For example, this is 10 meter per second square. So F, the higher F you apply, the higher the acceleration will result to the object, will be possessed by the object, like that. Same goes when you have a relationship such that A is inversely proportional to M. What does it mean? Which means that the higher the mass of the object, so the acceleration will be slower for a constant force. Okay, for a constant force. It means that, so we have again the toy car. Okay, this is a toy car. So we have two toy cars. Okay, so we apply the same force. Okay, so this is M is 1 kilo, for example. We apply the same force. Okay, same force. Force is 10 Newton. Okay, but this one is a heavier toy car, but we apply the same force. So this is actually 10 kilogram, for example. So I want to ask you, between these two cases, case 1 and also case 2, if you push that harder, 10 Newton, both of them, and this mass is 1 kilo and 10 kilogram, so which one will travel faster, will move faster? Okay, of course the lighter one, is it? This will has higher acceleration. Okay, for example 10 meter per second square. Okay, and that one is 1 meter per second square. Because if you have a lighter object, okay, lighter object, it will possess a huge acceleration if you than the heavier object. Okay, given that the force is constant for both of them. Okay, so remember the force must be constant. Okay, 10 newtons each. Okay, so like that. All right, but you can prove this by using the formula. So the first case, so remember F equals to ma. So F is 10 constant, 10 newton. The mass is 1 kilo, and the acceleration we want to find. So you just move the 1 to the left hand side. So 10 divided by 1 is 10 meter per second square. Okay, and for the second case, so this is F equals to ma too. F is constant, the same. M is 10 kilo. A is, we don't know yet, so you can divide 10 both sides. So I get A equals to 1 meter per second square. So you can see the result is the same lah. So you can see that the 1 kilo is has higher acceleration than the 10 kilogram. Alright, like that. So that's the second Newton's law. Okay, weight. Okay, weight is just the force of gravity. Technically, the force of gravity. Okay, the force due to the gravitational acceleration. Okay, so usually on Earth is negative 9.81 meter per second square, as we discussed just now. Okay, so the negative sign is due to the downwards direction. That's all. So it directed towards the center of the Earth. Okay, so that's the gravitational force due to gravitational force or gravitational acceleration. Okay, of course, so weight is vector quantity, so it's a force. It's just a special case for the force, but it is due to the gravitational acceleration. All right, so so the unit, of course, the same lah as the force, Newton, right? So the formula for weight is W equals to mg. So m is the mass of the object, g is fixed, 9.81, negative 9.81 meter per second square. Okay, so for example, if you want to calculate your weight, so you just put your mass. For example, your mass is 50 kilogram, you times with the 9.81. So this is actually your weight. Okay, so you can use your calculator. 50 times 9.81, so you got your weight lah. Okay. Okay, so next is the third Newton's law. Okay, so the third Newton's law is like when you do something, you will get something back. For example, if you do something bad, bad things will happen to you. So that's the analogy. When you do something good, good things will come to you back. So that's the analogy for the third Newton's law. Okay, so that's the analogy applies. Okay, so literally Newton's third law is just when you apply a force to some object, that object will apply a force to you. For example, you can imagine if you push, okay, if you push a wall like this, okay, you push a wall, the wall will push you back at the same magnitude or at the same value of force, but in the different direction. So that's all. Okay, for example, you have a wall. Okay, so this is a wall, and then you want to punch this wall. Sorry for my bad drawing. So it's like a cauliflower. Okay, sorry. Okay, so it's like, okay, so this is your hand. So you want to punch this wall. So this is a wall. Okay, so you punch a wall directed to the right, okay, ke kanan. So F ke kanan. So I will give some value, 10 newtons, for example. If you punch the wall, so as you reach the boundary of the wall, so the wall itself will push you to the left, okay, to the left. So the direction different lah, opposite direction, but the value of the magnitude of the force is the same, 10 newtons too. Okay, so that's the third Newton's law, right? So it is applicable. You can read over here when you push your hand. So the same lah, when you punch the wall like that, so the wall will punch you back, will apply a force you back. And when we walking, so when we are strolling or walking, okay, so you can see there is an action of opposite force. Okay, the third Newton's law applies lah. Okay, so you can see over here the FPG. So FPG is the force exerted on the few person foot by the ground. Okay, so that's by the ground. But in the opposite direction, so FGP, so the ground pushing or exert the force to the person foot instead. Okay, so the value of FGP is the same as the FPG, but in the different direction. So we put the minus sign. So minus sign means the different direction or opposite direction. Okay, so you can imagine when you're walking, okay, the ground push to you and you will push the ground back, your foot lah, I mean, right? So same goes with the when you launch the rocket. Okay, so when you launch a rocket, so I already drawn the rocket over here. So the fuel will be directed downwards. Okay, ini fuel, bahan bakar dia. So dia akan directed ke bawah lah, downwards. But okay, but the rocket will instead will be launch towards upward direction, oppositely, in the opposite direction. So for example, if the fuel can produce a force maybe 10 to the 6 Newton, okay, so it's a very huge force, for example. So this is actually an example, 10 to the 6 Newton. So the launching of the rocket requires, over here is F equals to 10 to the 6 Newtons too, but in the opposite direction. So this is F1, F2. So F1 is the same with F2, but in the negative direction, or in the different opposite direction. Okay, so the fuel downwards, the rocket will be will be launched upwards. Okay, so that's the third Newton's law. Okay, so what is momentum? So we are reaching this momentum. So momentum has to do with the force lah. Later we will discuss. Okay, momentum has to do with force. Okay, so momentum actually, the literal definition is basically the measure of the object resistance to change its state of motion due to force, application of force. Okay, so the formula is P equals to mv lah. Okay, P, momentum is P equals to mass of the object, mass of the object times the velocity. Okay, times velocity. So I missed the word. Okay, mass m times the velocity v. Okay, so it's like when you have a toy car. Okay, you push a toy car, so the toy car will have a certain velocity, right? So as it has certain velocity, so the toy car itself will have a momentum. Okay, so the momentum is given by m, the mass of the toy car, times the velocity of the possessed by the toy car itself, right? So that's momentum, right? And furthermore, momentum, as explained by the Richard Feynman. Okay, so the Richard Feynman said that if you have a something or a block, okay, which is not moving, okay, so when you push this, okay, when you push this block m, mass m, so as it moving, okay, as if it's moving, then it will possess a momentum. So that's all. So that's the definition given by by the famous scientist or famous physicist, okay, Richard Feynman. So you can search his name lah. So that's how he defined momentum. So actually the same lah, the definition is the same, the measure of the resistance of the object to change its state of motion, but Richard Feynman puts it in a simpler word like that. Okay. Okay, collision. Collision is just pelanggaran lah. When you have two particles, two or more, so usually two for your syllabus. So it will be moving at certain velocity, okay, and they will be hit or collide with each other. So that's collision basically. Okay, so the collision has to do with the conservation of the momentum. So the conservation of momentum is just simply, okay, I will write in another page. Okay, so conservation of momentum is very easy. So this is in one dimension, conservation of momentum. So conservation of momentum is stated that the sum of the momentum in a system is constant. Okay, which means that the final and also the initial momentum should be the same or remain the same. Okay, so the sum of momentum initial momentum is equals to sum of the final momentum in a system. Okay, all right, so this applies to our collision subtopic. We have elastic and also inelastic collision. So in elastic collision, okay, so we apply the same formula lah. Okay, pi equals to pf initial momentum equals to final momentum. So when we have two objects moving at v initial, so this is object MA, mass MA, and second object is at rest, MB. So VIB is 0, VIA is not 0. Okay, just set this VIB to have certain value, so for a general case. Okay, so you just add lah the because you know P momentum is mass times velocity. Okay, so PI, so you sum between these two objects initially and also finally. Okay, initially, so MA times its velocity, which is VIA, plus for particle B, MB times with the VIB, equals to the final condition. So this is actually the initial condition. So the final condition, the mass should be the same lah. Mass A times the V final A plus MB V final B. So this is the final condition. Okay. So in physics question, form 5 or form 4, form 5, they will give you the value lah. For example, they give you MA equals to MB equals to 1 kilogram. VIA is maybe 2 meter per second. VIB is 0 meter per second. And VFA is 3 meter per second. And you want to find VFB. So you just put the value over here into this formula, into this formula. You just substitute, and then you solve for VFB. So that's how it works. Okay. Alright. What is inelastic? Inelastic collision. Okay, so in elastic collision, just now for elastic, if this particle A hit the particle B, okay, they will move at different direction. Okay, they will not stick on to them they will not stick with each other lah. Okay, which means, for example, if VA is moving to the right and VB to the left, so this is initial condition. Finally, it will, for example, this will move to the left and this will move to the right. So this is example. So this is finally. Okay, so they move in a different direction. Okay, but this is for elastic. For inelastic, you have a particle A, they move to the right, and then this particle B move to the right too. So this is initial. And finally they will stick. They will stick together. This is combined velocity. Their combined velocity is to the right too. Okay, so this is VF. This is the final condition. Okay, so this is elastic. They will stick. A and B, they stick like a glue. Okay, but this for the elastic, they don't stick. They move in a different direction. So for elastic, I implement the same formula. Same formula actually. But for the final condition, because we know in the final condition, VFA is the same as VFB. Why? Because they stick. If they stick, they will have same velocity. Final velocity. They will have final velocity because they stick together. Okay, so they stick together. They will have same velocity because there are same in the same system lah. So you can just imagine when you are running and you hold your, for example, your friend's hand, so which means you guys are running together. So logically, your velocity and your friend velocity should be the same as you guys running, because you guys are holding with each other. You guys are sticking with each other. So your velocity and your friend velocity is the same, which is implement in our discussion lah, in elastic collision. Okay, so I can change Vf to be V. So V and this is V. So you can see we can factorize the V plus mv. So you can factorize the V. So the equation is like this. Okay, so that's just a slight change. What about explosion? So explosion is also we are using the same formula. Okay, we are using the same formula, but I want you to understand the concept of explosion. So explosion is when a particle breaks off. Okay, breaks off into random or into different position, random position lah. So that's the explosion. But in our case is this is the explosion of the cannon. Okay, the cannon and also the cannonball. Okay, so because the cannon and also the cannonball does not moving, so their initial velocity is 0. So they do not move. Okay, so the initial velocity is 0. Okay, 0 over here. So I can use the same formula actually from here. So this still implements the same formula. Okay, same formula, no worries. This is very easy. So same formula, but remember what I said, the initial velocity of the cannon and also cannonball is 0. So this is 0, this is 0. So anything times with the 0 plus with the anything times with the 0 is actually 0. So left hand side is 0. Okay, left hand side is 0. So we have this equation for explosion. Okay, like that. So we can rearrange MA VFA equals to minus MB VFB. Okay, so you can say in this case MA is for cannonball and VFA is the final velocity of the cannonball lah, as it released from the cannon. MB is actually the mass of cannon lah, the cannon. So you need to differentiate lah. This big machine or weapon is actually, we call this as a cannon lah, and this small is coming out from the cannon is actually the cannonball. Okay, cannonball, right? Okay, impulse. Next one is about impulse. Okay, so I want you to remember this phrase. So when a force is applied to an object, so there will be a change in momentum. Okay, this change due to the change in velocity, of course. If there is a change in momentum, okay, so you know that momentum is given by what? Momentum is P equals to M times the V. So what is the only reason this momentum to change? Okay, so we can look at the formula M times V. So does the M change in the system, in the, for example, an object? Can the mass of the object change if we don't insert, or if we don't take out the amount of matter? No. So the mass cannot change in this case, but the velocity can change. So the only way for the momentum to change is by changing its velocity. For example, at time 0 seconds, so the velocity is 2. At time 10 seconds after, so the velocity, for example, 5 meters per second. So it changes. Okay, so it changes as the velocity changes, the momentum will change. Okay, like that. So that's impulse. So impulse, just remember in your mind, impulse is the change of velocity. Change of momentum. So the formula, of course, impulse is given by J lah, symbol J. J equals to M. So the M is a constant. M is the same if we don't put or take out the particle or matters, okay, inside the object. So M is constant. So the only change is V. So V is the final velocity minus V initial. So usually we use U lah, U and V. So V minus U. So V is the final velocity and U is the initial velocity. Okay, so you minus them, there will be a change of the velocity. You times with the M. So you will result with the impulse or impulse. Alright, so that's impulse. Okay, so I explained this in our previous class. Alright, for impulsive, so last but not least is impulsive force. So impulsive force is just the rate of change of the momentum over time in collision. So this is actually specifically for collision lah. So the collision, of course, there will be what we call as collision time. Okay, so impulse is just the change of momentum over the collision time. That's all. So it's just impulsive force is just Ft is the change of momentum, which is J impulse divided by, remember J is what? J is impulse, this one. Okay, impulse, J impulse, right? J divided by collision time, which is T. So that's all. So Ft is equals to J divided by T. J is what? J is the change of momentum. J is impulse lah, or change in momentum, change in P. Usually in mathematics or in physics, this triangle is referring to change in. So we shorten the change in width into a triangle like this. So that's we call delta, change in. Okay, so we shorten certain width to be into certain symbol. Okay, in this case it's delta or triangle. So that's the triangle symbol. Okay, so actually the impulse is just this lah, simply is a force due to the change of momentum over time, over collision time. Okay, so you can read this short notes. Okay, so how can a seat belt and airbag save you from a car accident? So you can read over there. So the airbag increases the contact time. Okay, so still remember the formula is Ft equals to J divided by T. So you can see directly over here, because it says the contact time. So contact time is basically the collision time lah, T. So when the contact time increases, okay, so automatically this force, impulsive force, will be reduced, because Ft is actually inversely proportional to 1 over T. Inversely proportional to T. Okay, so higher time, contact time, so the lower force applied, or the impulsive force. But if you have in opposite, which means lower time collision, you will have a increase in impulsive force lah. So there will be a huge impact. So you will be, if the contact time reduce, okay, you will involve in the very horrible, terrible accident. So you will might be ends up in the hospital or so on and so forth. Okay, so that's why airbag is used. So the airbag, the aim or the objectives is to increase the contact time. Why? Because by increasing the contact time, the impulsive force can be reduced. Okay, so this is the relationship to prove it. So you can read the seat belt also doing the same thing. Okay, so this seat belt exert less force than the dashboard. Okay, then that dashboard does to stop you from moving forward. So remember the first Newton's law. So because the car is moving forward, so yourself actually technically is moving too. When there is a collision, there is a sudden collision, so your body will resist any change to stop you. So the use of the sealed bed is to hold you back so that you don't keep moving even though the car is stopped. So when there is an absence of sealed bed, which means you don't use sealed bed, so as the car collide, so it will experience a sudden stop, but your body don't want to stop due to the inertia. So your body will be punch forward, so you will hit the dashboard eventually, like that. Okay, so that's why sealed bed is important in this case. All right, so you can read over there. And also this the egg, okay, dropping the egg on the soft pillow, and also the using without using the soft pillow. Why? When we use the pillow, so it will prevent it from breaking. Okay, why? So it has to do with the impulsive force and also the time of contact. All right, so you can think about this first. Okay, you can search on Google, you can ask somebody why dropping an egg on a soft pillow prevents the egg from breaking rather than dropping it on hard floor. Why? Okay, so I want to hear your answer. Yeah, I think that's all for our discussion for this video. Okay, so see you in the next time. Bye bye.